ಸ್ಟಾರ್ಟ್
ಸ್ಟಾರ್ಟ್ ಆಲ್ರೆಡಿ ಹೊಡೆದೇನು ಇದೆಯಲ್ಲ ಈಗ
ಮತ್ತೊಂದು ಸ್ಟಾರ್ಟ್ ಹೊಡೆಯೋದು
ಸ್ಟಾರ್ಟ್
ರೆಡಿ ಆಗ ಓಕೆ ಒಂಥರ ಇದ್ರ ಮೇಲೆ ಹೇಳು. ಇವಾಗ ನಿನಗೆ ಗೊತ್ತಾಗ್ತದೆ ಇದ್ರ ಮೇಲೆ
ರೆಕಾರ್ಡಿಂಗ್ ಆನ್ ಅದ ಆಫ್ ಅದ ಪಾಸ್
ಆನ್ ಅದ ಆನ್ ಅದ.
Yes, good morning. Regarding your mid examination, first you have to register in examination with MREC exam portal. Then only you will get the examination link as well as day-wise password. If you are not registered, then you won't get the examination link at all. Okay, first duty you have to register. If you have any problems in registration, just through WhatsApp you have to message me if you have any problems in the registration. Okay, it is about the examination. Tomorrow onwards your exam starts. Okay, morning as well as afternoon. Morning session from the 9 to 11. That subjective exam is from 9 to 10:30. Subjective exam is from 9 to 10:30. Of 10:30 they will give a 15 minutes of grace period for the uploading. The same site itself you have to scan your documents, written documents, and upload. There is a limitation for the file size, that is of the 5 MB, that should not exceed 5 MB. Okay, through a cam scanner or any scanning method, you have to scan your documents neatly. That scanning should be, it seems neatly that should be visible. Your written document should be visible. Then only the evaluation people will going to evaluate your answer script. Otherwise it is difficult for the evaluators to evaluate your answers. Okay, even though if you are written correctly, if you are not scanned properly, then also it is difficult for you only finally to get your answer. That is one thing. Okay, you have to upload within same site only, within the prescribed time, within a 15 minutes. After the 15 minutes that it will be disabled. Only for 15 minutes time it is enabled. After 1 hour, first 1 hour they won't enable your uploading thing. After 1 hour they will enable your uploading, your document uploading. Then you can upload and you can leave. Okay, for every 15 members there will be one mentor. They will monitor your written process. You have to switch on your videos. Okay, that you have to on the video, then you start the writing. Then it is a process. It is the for the descriptive, for the objective also you have to, through the online exam only you have to write the objective. Already I have sent the subjective as well as the objective questions. So in the group only I have pasted the things. Already I have sent the 5 units model notes. Okay, further if you have any problems, any queries regarding the mid examination, you can ask. Okay. First thing is you have to register. Registration is mandatory. Then only you will going to write the exam. Otherwise if you are not registered, then it is problem for you. First mandatory thing. Okay, by today evening in the exam paper they will send a list those who are not registered. I will paste the same thing in the group. I will follow up the things who are not registered also. Okay. First thing is you have to register. Okay. Registration is mandatory. Through exam portal, MREC exam portal. We have posted that link. Through that link you have to register. Okay, registration is mandatory. Okay, probably today itself they will conduct the mock exam, that is online exam. How the system is there. They will give a guidelines how to upload all these things in the mock exam. Probably after the 2 o'clock they might be keep the exam, mock exam for all the third years. All the not only EC, all the branches students, so they will keep a mock exam today. Okay, try to go through your WhatsApp group. Then only I will inform, I will call to your CRs also when it is the mock exam. We will post a link in the web group, as well as I will call your CRs also for the information purpose. Okay, today we have to just go through the mock exam. If you find any difficulties, just ping me or call me regarding your internal exam if you have any problem, any doubts. Okay. Thing is, you have to write both the subjective exam as well as the objective exam. Previous semester you wrote only the online exam, online, that is also objective, or not wrote the subjective exam. This time you have to write both the objective as well as subjective to online mode only. Okay, are you clear now? This is about the examination thing, examination pattern, examination thing. Further, if you have any things, you can call me after this class. Okay. Already have been discussed basic things called the stick diagram, and what are the 4 basic layers, mass layers. That is N diffusion, P diffusion, that is metal layer, and polysilicon layer. You need to go through that basic 4 layers. That is there. Already you have been gone through the color code, which color has been used for the mass, that N mass and the P mass, P diffusion, N diffusion, and polysilicon, as well as metal. Okay, already have told these things. That is okay. For the polysilicon, red color for the diffusion, that is green color for the N diffusion. Metal is blue color, contact cut is black. Already I have told these things. Okay, what are the blue, and polysilicon is red, and green color for the N diffusion, yellow color for the P diffusion. Okay, this is about the N mass coding. I will not go into detail to these things. Already I have been explained these slides. I have told this stick diagram by drawing the N mass, that cmos stick diagram. Just see here, above is the P mass, above is this transistor 1 is the P mass, transistor 2 is the N mass, transistor 1 is
the machine never goes.
Transistor 1 is the P mass, transistor 2 is the N mass. Okay, gate of the connected to the gate of the P mass is connected to the gate of the N mass. X is an input, X bar is output, VDD is supply, and the ground line. Okay, already I think we have these things, this diagram, schematic diagram, circuit diagram. Okay, for this circuit diagram, we have to draw a stick diagram. Stick diagram, the representation. Already you know that one yellow line is yellow line. It indicates the yellow strip. It indicates the this yellow strip indicates the N diffusion, and this crossing of this diagram, it is called the P diffusion, polysilicon. This polysilicon is represented with the red color. This entire circuit, this entire stick, these two sticks, it represents the a PMOS transistor. This represents the PMOS transistor. Similarly, here also a NMOS transistor, green color, green stick with the red stick. If crossing green stick crossing with the red stick, it is called the NMOS transistor. Above is the PMOS and below is the NMOS. Just see there what are the things they have followed for the representing the symbols. Above is the contact cut. Contact cut is the represented with an that used with a block dot. Block dot is called the contact cut. If it is a metal, if the polysilicon crossing the diffusion, then it is a transistor. If N diffusion or P diffusion crossing the metal layer, then there is no physical contact. To make a physical contact, a block dot has to represent contact cut. A physical contact between these two layers is represented by the block dot. Okay, it is there. Next is just see the terminals. What are the terminals? Here, first terminal, it is the source and it is the gate and it is the drain. Here also drain, gate, drain, and below is the source. Just see the things called gate and gate are shorted. Gate and gate are these these two terminal are polysilicon terminal. These two gate terminal, input terminal, these are the polysilicon material layer, polysilicon layer. Okay, here this is a gate, below is also gate. Okay, these two gates are shorted, these two polysilicon layers are shorted and given as an input. Input is the X. Input is the X. Similarly, output is shorted with the drain of the PMOS is connected with the drain of the NMOS. Here through the it is a drain terminal. It is also drain terminal. It is connected with a one is below is the N diffusion and above is the P diffusion. These two are shorted with a metal layer. One more layer, metal layer. It is connected with a block dot, a contact cut. It is for the connecting between these two. Connecting between these two is connected with a metal layer and output is taken from this metal. Metal to metal, you should not use the contact cut. Same layer, it is in a physical connection. Different layer, metal to diffusion, metal to polysilicon, then you should represent a contact cut. A physical connection, a electrical path has to establish a electrical path, we have to use a contact cut. Then only a physical connection between these electrical path has been established. If you are not being used this dot, then it is an open circuit. There is no electrical path between these two lines. Okay, if the P diffusion crossing the N diffusion, then there is an electrical, that is a representation transit is a connection. Electrical path has been established. Okay, here a drain to drain is connected with the metal layer and taken as an output. It is called the X bar. Output is the X bar. Similarly, that VDD line, two rail lines. First we have to draw a two rail lines. That is, one is called the VDD line. Second is called the ground line. On these two lines, as these two rail lines, you have to a physical connection, that layers has to be formed. Okay, in between these two layers, that is two are a VDD and ground. These two are the metal layer. Wire is the metal. Here a wire, two wires. One is called the VDD line. Second is called the VSS line. On these two layers, you have to form these two transistors. Okay, one is P and second is the N. It is about the VDD and ground. It has to connect it with the a dot. Dot is a physical connection. Okay. Then first layer that below the VSS, that VDD layer, this is called the source. Okay. Below it is the source. Okay. It is the a stick diagram representing the representation of the CMOS. It is a stick diagram for an CMOS inverter. Similarly, it is the layout diagram. We'll go for the layout diagram later. This is the equivalent layout diagram, just similar to that only. The reason you should be represent with respect to the length and width ratios by using the design rules. We have to follow the minimum size, minimum length and minimum width of the diffusion and polysilicon. What should like we have to use that thing. Okay, it has represented with this. Okay, for the examination point of view, I have given 2 questions. 3 in the third model, 3 questions. One is called the design flow diagram. Second is the CMOS inverter. Third is the NMOS inverter. For the examination point of view, I have given this diagram. You have to draw this diagram. Okay, explanation part what color you have been used. If you have to use the color, that is crayons or the sketch pens to represent these colors only. These colors you have to use, these colors, particular colors we have to follow. Then only you will get a full marks. If you are not if you are drawn with help of the your pencils, you won't get full marks. This stick diagram purely by using the crayons or the color pencils, or by using the sketch pens, you have to draw. That represent blue color, red color, green color and yellow color. If you need only 5 colors are sufficient for drawing this stick diagram. 5 colors are sufficient to draw a stick diagram. One is called blue for the metal, contact cut is by using the black color, and red for the polysilicon, green for the N diffusion, and yellow for the P diffusion. This is an important. Okay. This is about the one stick diagram for the CMOS inverter. Same thing only, you can draw the other side. How to connect these things. The stick diagram can be by yellow line, and below that yellow line directly connected to here. It can be taken shorted, and same diagram only. Okay, just the arrow that the sides have been changed. That's only. The both diagrams will be similar. These both diagrams is the same way of representing the CMOS. Try to draw this diagram. For the CMOS inverter. Okay, it is a simple way of the drawing the CMOS inverter. This is the simple way of the drawing the CMOS inverter. A metal layer, a contact cut. Here represented by the X or the dot lines. Okay, above and below lines we have to draw a one X line. X indicate the substrate line for that fourth terminal. That is an input terminal, Y is an output, or Q is an output. Okay, this is about the CMOS inverter. Next is the NMOS inverter. NMOS inverter, just simple. Above one is called the depletion mode transistor. Below one is the enhancement mode transistor. It is the stick diagram. First is the circuit diagram for the NMOS inverter. Previous diagram you have used the CMOS inverter. In that PMOS as well as NMOS. In this NMOS inverter, both the transistors, that is pull up and pull down transistors, are NMOS. One is the depletion mode device. Pull up is the depletion mode, pull down is the enhancement mode device. Both are the NMOS transistor. Transistor 1 and transistor 2 both are the NMOS transistor. Transistor 1 is the depletion mode, transistor 2 is the enhancement mode transistor. That input device Vin has given to the enhancement mode transistor. That is, that gate terminal is shorted with the output. Gate terminal of the depletion mode transistor is shorted with the output, that is Vout. Vin, that is VDD and ground. simply to represent this, to indicate the short of the gate to the output, as well as the to indicate in a depletion mode, the implant is used, the yellow color. Here yellow color is there, no? This yellow color for the depletion mode, to indicate this transistor is depletion mode. Here one layer is there, no? This layer, this layer, it is indication of the transistor with the use of a depletion mode. This yellow color, implant layer, it is for the implant, that is used with the yellow color to indicate it is in a depletion mode. Here we have connected a one blue, first is two blue lines. These two are the two blue lines. These two lines are the blue lines, above and below they are the metal lines. Here it is a V in, it is the V in, and V out is taken from the, here it is a V out. Okay, this transistor is called the depletion mode transistor, and below transistor this is called the enhancement mode transistor. Above is the depletion mode transistor, below is the enhancement mode, that is the infrastructure of the stick diagram for a NMOS inverter. Okay, already I have told the things for the, this is for the stick diagram of an NAND gate. Here two parallel, it is a CMOS, two input CMOS NAND gate. This schematic are the circuit diagram for the two inputs. Just here they are not mentioned the interconnections. In this case we have to connect this A to A, here A to A, and these two B to B line. This is the B connections, and it is an A input. It is the two input NAND gate. A simple here a U shape, that is Y, and two U's have been connected. Just if you remember this one, it is sufficient for the drawing the two input NAND gate. U, it is yellow colors, above are the yellow colors. PMOS is represented with the yellow colors. It is a yellow color. This diagram is this stick, these two sticks are the in yellow color. The above is the yellow color, below is the green color. A polysilicon, that is a polysilicon is the red. Okay, it is our the two input NAND gate. Similarly, two input NOR gate. A NAND gate lo paina mass PMOS parallel untayi. In NOR gate, two PMOS are the series. The difference between that two things. Okay, just I will explain one more slide just for the examination point of view. This is an important for the examination point of view. In the lambda based design rule, in the mid exam they have given the, and for this only they have framed a 10 questions. Objective question lo e 5 points paine 10 questions unnai. What is the minimum width? Minimum width is the 2 lambda. A polysilicon to polysilicon, you have to specify 2 lambda. Similarly, N diffusion or P diffusion, minimum width is the 3 lambda. N well and P well 3 lambda, and metal to metal 3 lambda. Okay, what is that means? Here see the one is the N diffusion, second is the P diffusion. Minimum width of the diffusion is 2 lambda. Minimum width of the diffusion is, I will explain this, what is a lambda, what is the design rule later. Okay, just see here that minimum width is 2 lambda. Minimum width is the 2 lambda. That the size of this is 2 lambda. Spacing between the one diffusion to another diffusion, spacing between the one diffusion to another diffusion is 3 lambda. That is for the diffusion. Diffusion material, the width of the diffusion should be 2 lambda. Spacing between the one diffusion to another diffusion should be 3 lambda. Okay, if you use a polysilicon, one polysilicon to another polysilicon, one polysilicon to another polysilicon, spacing between these two are 2 lambda, and width of the polysilicon, minimum width of the polysilicon is 2 lambda, minimum spacing is 2 lambda. Similarly, metal to metal is 3 lambda. One metal to metal 1 to metal 2, metal 1 to another is also metal, same metals. If that is spacing is minimum 3 lambda, width of this is also 3 lambda, width of the metal 1 is 3 lambda. If you use a different metals, then metal size should be minimum of 4 lambda, spacing also 4 lambda. Okay. This is for the purely for the mid exam point of view. I have explained this diagram purely only for the mid exam point of view. We will go in detail these things in the next coming classes. What is the what is meant by design rule, what is the importance of design rule, what is the this lambda, what is the micro. Already I think I have been used this thing in the class. I have explained this one initially in I think I have 5 more minutes time. Initially in 1971 they have started with a space that is the minimum width of the channel width with respect to 10 micrometers. Okay, then they have reduced this to 1.5 1 micrometers. Then nanometer technology starts with 1989, that is 800 nanometers, 600 nanometers, and 350 nanometers, 250 nanometers, 180 nanometers, that is with respect to the channel length and width. Okay, in our college we have 90 nanometer technology in our lab. We are use this 90 nanometers technology. Okay, 65 nanometers and 45 nanometers. Right now the size that is in the 2021, there is a 10 nanometer technology. The designers, they are use a 10 nanometers technology things. Okay, we will see that what is that means, what is an importance of that. Okay, what is design rule, what is the definition of design rule, as well as in the fourth model we'll go in detail to the these NAND and NOR gates and some more logic designs, simple logic designs also. If you have any doubts regarding the okay, here these are the this is about the in the mid exam third model. I have not given this question. The second question ivalledu, only 3 questions have been posted in the site. That is summarize the VLSI design flow details. That is, you have to draw a diagram. Okay, illustrate a stick diagram for NMOS inverter. Right now I have explained that, as well as the illustrate the stick diagram for the CMOS inverter. These two, NMOS or the CMOS. You have to draw a stick diagram as well as the circuit diagram, that is schematic diagram for that one. It is about in the third model. And the first model, enhancement mode, depletion mode, transistor action, that is operation of enhancement mode and depletion mode transistor, as well as NMOS fabrication process, CMOS fabrication process. These 4 questions are important. Next in the fifth question, I have given compare CMOS and BiCMOS, and I have last question, how oxidation and lithography process are carried out. I have not given these 2 questions. Question number 5 and 6 I have not given. For the exam, I have not given construct a BiCMOS as well as the enhancement or depletion mode with their characteristics. I have not given these 2 questions. Next is in the second model, IDS versus EDS for the non-saturation saturation region. You have to derive a relation as well as draw a diagram, as well as you have to write the characteristic equations as well as expressions for the IDS expressions, and pull up to pull down ratio 4:1 ratio, that is pull up to pull down ratio of NMOS inverter driven by the another NMOS inverter. You have to draw a diagram, simple block diagram, as well as derivation for that one. Next is analyze parameter. Next, classify various reasons of CMOS inverter. Summarize the important of figure of merit and noise margin. Finally, I have given illustrate a schematic of CMOS, PMOS, NMOS and CMOS inverter in the second model. I have not given the one is called the latch up problem in CMOS. Next is conduct the conduction connect of the and output transconductance and output conductance of a MOS transistor. It is the transconductance and resistor transconductance and output conductance of MOS FET. I have not given in the exam. Okay, it is about the examination point of view things. If you have any doubts, you can ask. Regarding exam, tomorrow morning 9 o'clock your first exam starts. If you have any doubts, you can ask, otherwise we'll wind up today's class. Already I have been shared the objective as well as subjective questions. ఈ రెండు షేర్ చేశాను, సబ్జెక్టివ్ ఎగ్జామ్ది ఆబ్జెక్టివ్ ఎగ్జామ్ది. గో త్రూ క్లియర్లీ. ఓకే, రైట్ నీట్లీ ఎగ్జామ్. ఆల్ ది బెస్ట్ ఫర్ ది ఎగ్జామినేషన్. థ్యాంక్ యూ.